This is the last video, balancing equations examples. We're going to look at the examples, the 4 examples of balancing equations, examples 3. I'm going to do these questions a little bit differently. In the previous videos, I've been looking at the drawings and then working from there to figure out how to balance the unbalanced equation with the formulas. I'm going to do the exact opposite here now. I'm going to start with here and then draw what I'm representing in the equation below. All right. So let's do the first example. So we've got hydrogen chloride, calcium carbonate, calcium chloride, water, and carbon dioxide. All right. So let's start with the calcium, for example. So we've got one calcium, one calcium. So they're balanced. That's okay. Let's try chlorine. We've got 2 chlorines and 1 chlorine. So in order to do that, the only thing you can change is the coefficient in front. So if I put a 2 there, now that represents 2 chlorine atoms. All right. So what we do over here then is we can represent that with a drawing. 2 chlorine molecules, 2 chlorine atoms, the balance of 2 chlorine atoms that are actually drawn for you right there. Okay, let's look at the carbons. 1 carbon, 1 carbon. So those are balanced. The only thing that's left now is the hydrogens and the oxygens. Okay, so let's have a look at that. So we've got 2 hydrogens there because the 2 multiplies everything in the formula. So 2, and we see there's 2 in the drawing as well. Look at the product side. We've got 2 hydrogens there. So the hydrogens are balanced. Let's look at the oxygens. We've got 3 oxygens there because of the 3 subscript. Let's count the oxygens here. We've got 1, 2, 3. So that gives us 3 oxygens. That equation is balanced. Let's go to the next example. So we've got 1 potassium, 1 potassium. That's balanced. We've got 1 nitrogen, 1 nitrogen. That's balanced. We've got 3 oxygens. And we've got 1, 2, 3, 4 oxygens. So that's not balanced. So we have to figure a way to actually do that. Okay. So if we add another molecule of potassium, I'm just going to do this by trial and error. Let's put a 2 there. So now we have 2 potassium nitrates. Okay. We're actually missing a drawing up here. Actually, no, there's potassium and then NO2. Sorry. So let's add another potassium nitrate right there. Okay, so there's your potassium nitrate. We have 2 of those molecules because we brought a coefficient of 2 there. So that gives us 6 oxygens now. Now here we've got 1, 2, 3, 4 oxygens. So that's still unbalanced. Let's go actually switch to the potassium and the nitrate. We've got 2 potassiums, 1 there, 1 there. 2 nitrogens, 1 there, 1 there. But we only have 1 of each right there. So let's put a 2 in front of there. Let's see what happens. So now we've got 2 potassiums, 2 nitrogens, 2 potassiums, 2 nitrogens. We have 6 oxygens. 2 times 2 gives us 4 oxygens, plus the 2 there gives us 6. So now the oxygens are balanced as well. But what we can do now is just add our potassium and nitrogen oxygens there as well to represent that 2. Our equation is balanced. Let's go to the last 2 examples. Let's start with sodium. We've got 1 sodium, 2 sodiums there. So we can see that there. 1 sodium, 2 sodium. So if we put a 2 in front of there, now we've got 2 sodiums, 2 sodiums, so the sodiums are balanced. So let's represent that with our drawing. So 2 molecules of sodium bicarbonate, 2 molecules of sodium bicarbonate, 2 sodiums, 2 sodiums. Let's look at something else. How many carbons do we have? Well, we have a carbon in here, but we have 2 of those molecules. So 1, 2 carbons. We have 1 carbon there, 1 carbon there. So the carbons are balanced. Let's look at the hydrogens. We've got 2 hydrogens, right? 1, 2. 2 times that hydrogen gives us 2 hydrogens, and we have 2 hydrogens in the water molecule, so those are balanced. let's look at the oxygens. We have 6 oxygen atoms there because 2 times 3 gives us 6. Count them up here. 1, 2, 3, 4, 5, 6. Let's look at the number of oxygens over here. 3, 4, 5, 6. So our equation is balanced. Then finally, the last one, we've got 1 carbon, so that's balanced. We've got 4 hydrogens, 2 hydrogens. Okay, so that's not balanced. So if we put a 2 in front of there, right, now we've got 4 hydrogens. 2 times 2 gives us 4. So let's add another water molecule here, and that gives us the extra oxygen that we need. 1, 2, 3, 4. 2 times 2 gives us 4. We've got 1, 2, 3, 4 there. We've got 4 hydrogens there. So our hydrogens are balanced. Carbons are balanced again, 1 there, 1 there. So the only thing that's we have left to check here is the oxygen. So let's count those up. We've got 2 oxygens there. But don't forget about the water. 2 times this oxygen there gives us 2 oxygens as well. So we have a total of 4 oxygens there and only 2 there. So if we put a 2 there, 2 times 2 gives us 4. So we'll add those oxygen atoms there. So we've got 1, 2, 3, 4. We've got 1, 2, 3, 4. Now this equation is balanced.